Hello ladies and gents, welcome to another repair video. Today we're going to be working on this PS4 FAT, which has been sent in for no display. The customer who sent this in contacted me yesterday and asked me if I do APU reballs, which is obviously not the case because we apparently get a white light on this thing. So I messaged her back and I told her that it was 100% not going to be the APU if it's got a white light, and it's more likely going to be something to do with the MN86471A HDMI encoder IC, or it's going to be something to do with the hard drive. So basically I told her to send it in and I could fix it for around about £40, which is around about my going rate for the HDMI encoder IC. It's a relatively simple job. It's a little chip on the board. It's located around about here on the back side of the board, and it's responsible for taking the audio and video signals and basically just retiming them, mixing them all up and synchronizing them before we send it out to the HDMI port. And that's the most common thing that goes. Another thing when we don't get no display is going to be the hard drive. There is one way to tell if it's going to be the hard drive, and that's if we get two black lines on the display. So if the display turns on and we get two black lines as if it's got a safe mode box but with no text, then it's most likely going to be down to a hard drive. If it doesn't turn on at all, or the monitor shuts off for whatever reason, then it's probably going to be something to do with the HDMI circuit. So first things first, let's take a look at the HDMI port. And the port looks absolutely beautiful. So that looks mint. Now there is one interesting thing about this, and that is the fact that the stickers are still here. So if the stickers are still here and these haven't been touched, I've tried to peel these away, and if the stickers are still here and haven't been touched, then how has this place in Birmingham determined that it's an APU fault if they haven't taken this bottom case off? Because I can't get the motherboard out without taking this bottom case off. So it's going to be quite interesting to see what they've actually done inside. Now these two stickers have been taken off, but these two stickers here, the one on each end, the black ones, I mean, I'm peeling away at that, and I do have nails, so you know, I'm peeling away at this, and this hasn't been removed. These stickers, these will come away way easier than that, unless they've put brand new ones on. And personally, I've never been able to find replacement stickers for these. It would be nice to find them. So if anyone does know, let me know down in the comments, and I'll probably buy some. But it's going to be interesting to see what they've actually done to this, because this is the second time in as many days that I've come across customers who have taken their stuff elsewhere. There was a lady, which I've got three consoles that belong to one lady. The first one she purchased and then found out the HDMI port was broken. She didn't check it, so I fixed that for her. The second one had a disk drive issue, and that apparently went to a shop in her local area, and basically they said that it was unfixable. And they also broke the SATA connector on another console. So we know they broke the SATA connector on the disk drive console, and basically I managed to fix it. They said that it was unfixable because the disk drive had failed, and I managed to fix it. And the third one was water damaged, which I'm still working on at the minute, but I've got the water damage fixed, and they basically said that it was not worth doing, and I got it done in an hour. The only issue with that one now is it's not reading discs because the ARM chip has failed. So unfortunately that's going to be a partial fix, but it's it's like I said, it's the second customer in as many days that's contacted me saying that they've took it to a shop and they've determined it to be something that it's not. And I'm getting quite sick of it, to be honest, because shops like that give people like me a bad reputation. I take all of my work very seriously, and I take pride in my work, and I stand by my work. And for people to just come along with absolutely no clue what they're doing and just mess it all up and pretend to be a professional and pretend to be something that they're not is downright disgusting. Anyway, let's get back into this repair. So, like I said, this could be down to one of two things. It could be down to the HDMI circuit, or it could be down to the hard drive. So the first thing we're going to do is we're going to pop a HDMI lead in here. And I'm using my HDMI capture card so I can pick the display signals up on the PC. So it means I don't have to turn my camera around anymore, which is always quite handy. The first thing we're going to do is I'm going to switch over to my desktop cam. So let's switch over to the desktop and load up the camera. And you'll see that it loaded up USB video. So let's turn it on. And I'll keep the main cam in view just so as we can see what's happening with the console at the same time. And let's see if we get a white light. There we go. Okay, so that's gone to a white light, but we're not getting nothing at all on the screen. And I cannot see any black lines either, which means this hard drive is probably fine, and it's probably something to do with the HDMI encoder IC. So the white light stays on, and there appears to be nothing wrong with the actual console itself. So like I said, this is probably going to be down to one of two things. It's probably going to be down to the hard drive or the HDMI encoder IC, and I'm going to say the HDMI encoder IC, and the reason for that is literally because the console goes to a white light. We don't get any faint black lines on the screen or a different colour on the screen as if it's trying to go into safe mode. So yeah, that's just rebooted, which means that the hard drive was being checked, and I'll just wait for it to go to a white light again, but that means that it's gone through the hard drive check and rebuild if necessary. You know, when you don't turn it off properly and it comes up checking hard drive status the next time you turn it on. So that's what's going to have happened there, and that's the reason that it's going to have rebooted. So yeah, I mean, let's just wait for it to get to a white light again just to make sure. And there we go. So we've got the 3 beeps there as well, so that means that this console has turned on. This drive appears to be working normally. So let's load in a disk just to check, make sure that the disk drive takes a disk in. And it does. I'll obviously check functionality of the disk drive afterwards once we've actually repaired this. But let's get into the repair, shall we? Okay, so first things first, what I'm going to do is, I'm sick of having to replace these thermal pads because I lose them. So I'm just going to take them off the board itself. I'm going to pop them back onto the actual chassis, the metal chassis, because I keep losing them and then I have to replace them. Because these consoles will overheat without those thermal pads. Okay, so that's literally all I've done. Just pop the thermal pads into their proper place on the chassis itself, because we're going to be working on the board, not the chassis. We will do some cleaning later on, but for now we're just going to be working on the board. So before I go ahead and do any work, I'm going to remove this old thermal paste because that'll be replaced anyway. And this is technically a job that can be done without removing the motherboard. However, there is a risk of melting plastics, and it's relatively simple to just remove the motherboard. So I have done them inside the chassis before when I've been in a bit of a rush. If I'm backed up and I'm trying to get work done and back out, I have done them with them still in the chassis, but I usually take the motherboard out. I wouldn't recommend it. Okay, so that's nice and clean. So that's ready for some new thermal paste later on. So the first thing I want to do is just have a look at the actual HDMI circuit itself. And there's a couple of places we need to look. We need to look here and we need to look on the back as well. So I'm going to start with the back, because I'm probably going to have to remove this anyway. So what I'm going to do is I'm going to use the heat gun and some solder. I'm going to remove this ground plane here, this little shield. Remove that from the board so as I can access the HDMI encoder, which is situated underneath that shield. That shield's there to prevent signals being affected by noise, and to access the chip we need to remove that, but it is soldered on. So what I like to do first is I like to add some fresh solder, some leaded solder, and then I can use the heat gun along with the soldering iron to melt these connections and remove the shield safely. Because what will happen is, if you just use a normal heat gun, what's likely to happen is you're going to rip up the ground plane that's here, and there's obviously wires and stuff that are going through to the other side of the board, and if you rip up one of the wires with it, then you've got to do an entire rerouting of the circuit, because you'll have damaged the wires, and the wires are what helps the circuit to travel from one side of the board to the other. So basically we need to make sure that we don't damage that ground plane, and I've seen it many times before where people have removed these and they've damaged the ground plane, and the first time I did one of these I actually did the same thing myself. So I'm not going to pretend I'm perfect, because I'm not. I think I've only ever done it once, and I learned from my mistake. Believe me, I learned from my mistake very, very quickly. I got really lucky on that one, but I still learn from my mistake very, very quickly. And we all make mistakes, but it's whether or not you can rectify them afterwards. So we don't want to rip that ground plane up, like I said, and it takes a lot of heat to remove these, because the heat gets sucked up by the ground plane. So by adding leaded solder, we're lowering the melting temperature of the lead-free solder, and we can also use the soldering iron to help transfer the heat direct. So while we're using the heat gun, we can also run the soldering iron across, and that will assist it with transferring the heat to directly in that position. So the heat gun I use is an AOYUE 968. It's not really the best, and it doesn't give out a true 480 degrees. So yeah, it's not the best heat gun, and this task is relatively hard with that heat gun. So that's the way I like to do it. Make sure that I don't damage the board when I'm removing this shield. Okay, so the soldering iron should be relatively warm now, and I've just taken a chip off another board. So I'm going to be using that chip as a donor board if needed. I just thought I'd do that while I was waiting for the soldering iron to heat up and things. So like I said, what I'm going to do is I'm going to add some leaded solder to this area here, and then I'm going to use the heat gun and in conjunction with the soldering iron to remove the shield. So I'm going to start by adding some flux just to the areas which have got solder points on. And there are a few solder points here. We've got a long one here at the edge, then we've got a little one just here. We've got a mid-sized one here and a little one here. And all of those are 4 solder points. So I'm just going to add some leaded solder to each one of those. So I'll add some solder to the tip of the iron. And then I'm going to heat up the area. And just add some leaded solder to it. So that one should be nicely mixed up now. Let's do the same for this one. And the same here. Good. So that's got some leaded solder mixed in now. Hopefully that's going to lower the melting temperature a little bit. Just prevents us from damaging the board, that's all. And now what I'm going to do is I'm going to put my tweezers closed and then prop them underneath the actual shield itself. And what that's going to do is it's going to cause it to want to spring up when the heat gun melts the solder. So we'll start by just focusing on the one solder point. And I felt that give way. So now I can grip the actual shield properly. And I'm just going to put slight upward pressure on this shield. So I'm not pulling on it, but I am putting slight upward pressure. So I'm going to feel it give way. Just like that. And there we go. So that's come off now with absolutely no damage whatsoever to the board. So we'll pop that shield to one side. We haven't actually damaged the shield or anything. So that shield can be reused, which is awesome news. One little thing, always put the shield back on when you've done, because it will interfere with the circuit. Okay, so I'm going to wait for that board to cool down. because that board is going to be very, very hot right now. But while it is still hot, I'm just going to clean up the area just so I can work on it. I'm going to use some isopropyl alcohol on the end of a cotton swab and just get rid of this flux that's melted onto the board. Okay, so the area is nice and clean. The board's going to take a while to cool down. It's still very, very hot around that area. Okay, so the board should have cooled down sufficiently enough now. So what I'm going to do is I'm going to get my multimeter and I'm just going to test some of the components around the area. And I'm pretty confident that this is going to be down to the HDMI encoder IC. Okay, so I've popped my multimeter into continuity mode. The continuity mode is the mode that's going to go beep when we complete the circuit, and we can see a little signal or speaker symbol here. That's going to indicate that it's in continuity mode. It's also on the top of the display. So we're in continuity mode. What we're going to do is we're going to test these EMI filters first, and we're going to see if these have got continuity. So the EMI filters are essentially just coils of wire, and they're put in place to basically filter out noise from electrical interference. So when it comes from the APU, the video signals, it comes from the APU and then it goes to the HDMI encoder, and then from there it goes to these EMI filters, and then from the EMI filter it goes out to the HDMI port. But before it gets to the HDMI port, it must filter through these. And what can happen is one of several things. The first thing that can happen is these EMI filters can go bad. So these can either blow as open circuit, so basically there's no continuity between the top point and the bottom point. They can short out against the EMI filter next to it, which would cause distortion, or they can short out to ground, which again would cause distortion and signal loss. So if these are distorted or blow open, then it breaks the signal and or mixes up the signal before it goes out to the HDMI port, and then the HDMI circuit on the TV can't decode the signal properly. So realistically the only path to ground for these is through the chip. So if we've got a short on any of these EMI filters here, and there are 8 in total, there's 2 on each one of these components, and if we've got a short on any one of these here to ground, then the most likely scenario is going to be the chip itself, because it's the only realistic path that these EMI filters have got to ground. If they are not continuous from the top of the filter to the bottom, then it's going to 100% be a filter issue. And if they're continuous from one filter to the next, then it could be the filter or it could be the chip itself. And if these test good, then it's most likely going to be the chip. So if these all test good, we'll change this chip and then try the console and see if it works. So let's start off by testing the filters. So I'm going to pop one probe on the top of the filter and one probe on the bottom, and that should be continuous. And then what I'm going to do is I'm going to pop one probe on one filter and one probe on the filter next to it. They should not be continuous. And then I'm going to pop one probe on the filter and one probe on ground, and that should also not be continuous. And that's going to tell us whether these filters are good or not. So we'll start from the right hand side, doesn't matter which one we start from. And these are rather difficult to test with longer test probes. Let's just check all of them against ground. So all I'm going to do is just run my probe against all of the pins. Make sure that I'm getting a connection by doing it several times. In different... Oh. No, I was touching that there then, never mind. Let's do it from the bottom. Okay, so none of those are shorted out to ground. Okay, so it's easier to do it this way. Good. Doesn't appear shorted to the one next to it. Good. 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 Okay, I can't get a reading on that one, so I'm going to pop under the microscope and just make sure that I'm actually hitting the target. Okay, so those filters are definitely good. I've just tested all of those, and I know for a fact I'm hitting the target, and they are good. So they're all beeping where they should be, and they're not beeping where they shouldn't be. So I'm going to put my bets on this chip here, which is the most common thing that goes on these. So I'm going to get that removed. Okay, so let's add some flux. So what I'm going to do now, I'm going to get the pads prepared for some fresh solder, for a fresh chip. So I'm going to add some leaded solder to all of those pads. That's okay. So let's clean up. Okay, and I'm going to inspect it under the microscope just to make sure that we've got no issues with pads or anything, because it took an awful long time for that to come up. So I'm just going to double check, make sure. Okay, I'm happy with that. Right, so what I'm going to do, I'm going to change this solder here as well to leaded solder, just to make it easier to get that shield back on. Okay. So because these are ground pads, I do like to use the heat gun to assist. Okay, so that's been changed over to leaded solder. That's going to be a lot easier to work with when we do go to put the shield back on. So let's give it a good clean. Good. Okay, so ready for a new chip now. So I'm going to pop that into position. So these go with the chip facing upside down. Okay. So let's use the hot air gun. Right, so that appears to be in position, but I'm going to double check again under the microscope. We can never be too sure, and my eyesight is shocking. Okay, and that is in perfect position. So what I'm going to do now is I'm going to run the soldering iron across all of the legs, just to make sure that they're all nicely soldered, and then I'm going to check under the microscope once again and just make sure that we don't have any loose pins, and then we should be good for getting this tested and put back together. Okay, so let's just take the soldering iron, and I'm just going to run my iron across all of these pins using the drag method, and I'm going to use the heat gun as well just to assist in transfer. Okay, so like I said, what I'm going to do now, I'm going to check under the scope, just make sure that all of these pins are connected. So first of all, I need to clean up the area and make sure that we don't have any flux residue. And the reason for that is just so as we can actually see the pins properly under the microscope, because this flux residue will shine off the microscope and affect the vision because of the microscope ring light. So I'll just clean up all of the flux residue using isopropyl and a toothbrush. And I'm not going to put the shield back on until I know 100% that this is working and that it's not going to give me no display, because I don't want to have to take anything back off again afterwards. And the problem is, most of the time I use chips off donor boards, and when you do that you can never be sure whether they're good or not. This one should be, but you can never really be sure whether they're good or not. Okay, so that's nice and clean. So I'm going to have a look under the microscope and just make sure that all of those pins are connected. And like I said, all I'm going to do is I'm going to run across each and every pin using the tweezers, and I'm just going to nudge the pins with the tweezers, make sure they don't move, make sure they're nicely soldered, and then we should be good to go. Okay, so they all seem good. So while I'm here with the microscope set up, what I might as well do is just test the little components around it, the little filters and capacitors. Just make sure that they're all good. So let's set it into continuity mode, And I'll check the capacitors first. Good. 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 Okay, so all of those are good. Let's check the EMI filters again, just make sure that we haven't had any sort of issues. Good. Excellent. Good. So everything's testing okay there. And what I'm doing now is just inspecting under the microscope this HDMI area. And it all appears to look okay, no burnt components. I'm going to do the same nudge test on the pins on the HDMI port, just to make sure. Just because I'm under the microscope. Excellent. So the HDMI port checks out. This area looks absolutely mint. Yeah, I don't think there's anything else to test. Let's get this actual console tested, shall we? Alright, so I think we're just about ready to get this tested now. So what I'm going to do is I'm going to take some fresh thermal paste. That's plenty. Maybe a bit too much. There we go. So that's more than enough thermal paste on there now. But before I do that, I want to get the rest of the console clean. Because I don't put these back together without cleaning them out first. It's just a little rule I have. And if this all works, then all I'll have to do to get this fully reassembled is take the top plate back off and solder the shield on. So if I clean it now, it's going to save me having to take everything back apart, reapply thermal paste and everything like that. So it's just not worth leaving it. I might as well do it now and actually get this thing reassembled properly. Because either way, once we do get this working, which we will, and the reason that we will is because it goes to a white light. But once we get this working, we can basically call it done and then just put it back together and finish the job off. So I'm going to get this all cleaned out. I'm going to brush all these parts out and make sure they're all nice and clean, and then we can carry on. Okay, so that took all of about 2 minutes to get everything nice and clean, and you can see that everything is almost perfect. Okay, so let's get this fan screwed back in. So only 2 screws go in the fan from this side. One goes here at the side, on the right hand side. And the other one goes here in the middle. The other one goes in from inside the metal frame. So this metal frame here, there's a screw just here, and that allows us to, sorry, not there, just there, and that screws into there. So we don't put a screw in there, we put it in through this side. And as you can see, that's all nice and clean. Absolutely perfect. So basically, when this console returns to the customer, it's going to work perfectly for, well, many months to come in terms of cooling. It's not going to overheat. Right, let's get that back in the proper position first of all. There we go. So in terms of actual cooling, it's not going to have an issue now for at least a couple of months, at least 6 months, 12 months. I would say more like 2 years, but you can never be sure. It depends on the environment. Okay, awesome. So now we're ready to just remove the thermal paste off here. So again, we're just going to wipe that away with a cotton swab. Make it all nice and clean. Make sure there's no old thermal paste on there. There we go. And now we're ready for the board. So let's pop the board back in. And like I said, I'm not going to put that shield on yet, just in case it doesn't work. But the shield's going to be relatively easy to put on without removing the motherboard again. So I'm not overly concerned about that, to be honest with you. Right, okay, so we have all the thermal pads there. Good. So let's pop that on. So literally all this is doing now is just preliminary testing, and then obviously if it works we'll reassemble it, and if it doesn't then we haven't got to disassemble too much to get the board back out again. But honestly, I'm going to say that it's most likely going to work. Right, so somehow I lost a screw. I'm not concerned about that being stuck up, by the way. I can sort that out in a bit. But somehow I lost a screw along the way for the heatsink, so I had to find another one, which is always quite annoying. Goodness knows where that could have gone. Probably fell on the floor or something. Okay, so hard drive's in. Right, so let's pop the disk drive and the power supply in. I'm not concerned about the Wi-Fi antenna for now. Oh, actually, yes, because it's going to save me having to disassemble the power supply again. So let's get that in now. Just in case. So let's just route that in the proper position. Let's pop the black screw in as well, the black Phillips screw, because like I said, it's going to save us having to do it later on. There we go. Okay, all of those are in. Power supply's in. And we are ready to test. So let's get the power cable and plug that in, along with the HDMI lead. Right, okay, so we're going to turn it on. 3, 2, 1. And are we going to get anything on the screen? Oh, we've got a display. Yes. That's it. Yes. So the question is it going to load into 1080p? So let's let that reboot, and then we'll go ahead and test the 1080p. Make sure it's working. Okay, so literally just waiting for the display to come back on now. It should come back on. It did come on just, so it should come on now. Right, okay. Nothing's showing. I think that's my HDMI capture card playing up, to be honest. Yeah, it is. Right. Or is it? Yeah, there we go. Okay, so let me get a controller and let me check, make sure that we've got 1080p. Right, okay, so let's just get this tested real quick because the customer is on the way. She's really desperate to get this back. So yeah, let's just make sure that one, we can connect to Wi-Fi. It's a bit choppy, but that's the... Yeah, that's working, that's fine. It's a bit choppy, but that's just because it's a HDMI cable. The HDMI capture card, not the console itself. Let's check the display, make sure that we're in 1080p. Resolution, 1080p. Yep, we're in 1080p, that's excellent. So that's all working. So, finally, let's check a disc, make sure that works. Yeah, excellent. Right, okay, so let's get that disc out. And let's turn it off. And now we're going to get this thing reassembled. So the first thing I'm going to need to do, obviously, is get the shield put back on. So I'll just wait for this thing to shut down. Excellent, there we go. Just wait for that white light to go off before I remove the HDMI cable. There we go. Awesome. So like I said, let's get this thing back together. So I'm going to take it slightly apart again just to put the shield back on, but it's not worth putting that shield on until we know for sure that the console's working. But I've got to be quick now just because the customer's already on the way. She's going to be about 25 minutes, so that should be enough time to get this thing back together. I don't generally like rushing, but it's just one of them things. Not really got much choice. Yeah, I think the kids are pretty bored without it because they've been without it for a while, so I think her kids are pretty bored. And it's a bit annoying the fact that this customer took this to a shop and they told her that it was down to the APU and not down to the encoder IC. If they don't have the skill set to fix it, then just send it somewhere who does. Set up a B2B contract with the person that you're sending it to. Get them to do it you at a discount price so you can still make a little bit of money for the time you do spend on it. And happy days. Even I send stuff to other people sometimes if I can't figure it out. I'm not going to pretend like I know everything because I don't. What am I doing? I didn't need to take that out. Let's just see how that thermal paste spread beautifully. So that thermal paste spread really nicely. We're not missing one of those. It is on there. So there's no thermal pads missing. Okay, so let's just pop these back on there. And then I'm going to take the shield. And I'm just going to pop that into position. First of all. And then I'm going to try and tack it down. Just enough so as we can use the heat gun. Okay, that should be good that side. Good. So that's soldered back on there now. The soldering joints on those don't have to be absolutely perfect. It's literally only there for helping to filter out noise. So that doesn't have to be perfect, and as long as it's on there, it's good. So let's get the case back together now, because we've got to put all of these screws back. There we go. And the final piece of the puzzle. There we go. Right, so let's give it one final test while we still have it on the bench. Let's make sure that it still works and that there's no issues arose since we took it back apart. Okay, and there we go. So that is all done. Yep, that's loading up GTA. Excellent. And that's pretty much it. Right, so just to summarise then, this console was originally sent to a local repair shop who decided to tell the customer that there was an issue with the APU. Now, just given the fact that this console had a white light, it tells me that there's never going to be an issue with the APU on this. If you get a white light, then you generally have all system checks passed, and we typically call it the white light of death. So that's when you get a solid white light, but nothing at all happens on the screen, and that's usually caused by either the hard drive or the HDMI circuit itself. The APU issues typically cause a blue light of death, and then they will need a reball. But in this situation, there was absolutely nothing wrong with the APU, and it's pretty clear that the shop either just didn't want to deal with it or they didn't have the skill set to deal with it, so they just told her a pack of cobbles. So by replacing the MN86471A HDMI encoder IC, that's a 64-pin IC, and the manufacturer is Panasonic. So it's a Panasonic MN86471A. It's not to be confused with the same chip on the PS4 1200 series Pro and Slim. That's the MN864729. So they are different chips. The 729 is a QFN. This one's got legs. But by replacing that chip, we're able to restore the display and get this fully working again, and this console can live on for, well, as long as it wants to live on for. So thanks very much for watching, guys. I hope you enjoyed the video. I hope you found it helpful. Let me know what you think down in the comments down below. And if you want to see more trying to fix videos where I fix mainly consoles but sometimes other things too, be sure to hit that subscribe button, turn on bell notifications so you're notified every time that I upload. I'm trying very, very hard to get to 5,000 subscribers by the end of the year, and if you could hit that subscribe button, it would really help the channel out a lot. Also, be sure to check out my Facebook page, facebook.com/filthyfixes, and you can get in touch with me there where you can ask me any questions or organise your own repair. So thank you very much for watching, guys, and until next time, see you later. Bye for now.